Nathan here, welcome back to another video for the PGL2D Alpha series. And in this video we are going to discuss the collision class. And in this class, this is going to be responsible for checking collision and also performing collision detection and returning a normal collision result. So if two objects collide, what is the normal for that collision? And we're going to use that when we do vector reflection, which we will use in our paddles game. So let's right click our collision folder and let's go to add class. Let's call this collision. And I'm gonna minimize the solution explorer. It's gonna be a public static class. This is just going to help us check for collision, so do not need to make an object to this, so we're just going to make it static. Now the very basic thing we want to do is check to see if one object collides with another object. And the easiest way to do this is to check for rectangular collision detection. In a future video, and when we get this in beta and final release, we're going to check more than just rectangle collision detection. But for now, this is just the basics of what we're going to be doing. So public static bool, and collision only works, in this case, it'll only work for objects that can move. So we're going to do rectangle collision, and we're going to provide movable entity A and movable entity B. We're going to set those up as the parameters. And what we're going to do is we're going to check rectangular collision detection by using the rectangles of those entities. So we're going to return rectangle or rectangular collision. A.rectangle, B.rectangle. And we're going to create another method here, public static bool rectangular collision. It's going to accept rectangle A and rectangle B. And it's going to return A.intersects B. And I'm just going to adjust the naming here so it works. Okay. So we call rectangle collision, and we provide two movable entities to check. And that calls rectangular collision with two rectangles. And it just checks to see if those two rectangles are collided. The last method we're going to create for now is the rectangular collision that we want to retrieve a normal based on the collision. So we're going to do public static bool rectangular collision, movable entity A, movable entity B, out vector2 normal. So it's going to be a public static bool rectangular collision, and the parameters will be movable entity A, movable entity B, and out vector2 normal. This is going to guarantee that we're going to get a normal. It could be vector2.0, that could be our normal, but it will provide a normal. Normal will be vector2 in the case where no collision has occurred, so it will return false and vector2.0. Okay, so let's set that condition up. Normal is equal to vector2.0. Alright. If not rectangular collision A.rectangle and B.rectangle. So if it did not collide with another rectangle, we're going to return false. So if there's no point to continue, there is no rectangular collision, so we return false, and we return the output will become vector 2.0. If that is not the case, we continue. So the way we continue with this is we get the delta position. A position minus B position. We get the change of position. We get the delta of X and delta of Y. So delta is equal to A dot position minus B dot position. Then what we do here is we need to get the absolute value of X and Y. And we do that because there's a few cases where we want to get the absolute value in our checks. And we do this before we do our checks in order to not do repeated processing. Now, if you do absolute value of a variable 4 times, there's really, you don't need to do that. You just create a variable to hold that data and then just check that variable. So we're going to get an absolute value of X and Y. Var abs delta X is equal to math.abs absolute value delta.x. Var abs delta Y is equal to math.abs delta.y. Okay, so let's look at the first check. Collision on the right side. If delta.x is greater than 0, so the delta, the change of x between one object and the other object, if that is greater than 0, that means the change is going to the right direction. So we are getting a collision on the right side if that is true, and the absolute value of delta y is less than b.rectangle.height divided by 2.0. So that will check if the absolute value of the delta y, if that is less than height divided by 2. So since we're using the origin as the center of our object, if, for example, let's say the delta y, the absolute value of delta y, is equal to half the height, that would mean that our object is at the bottom right corner of our other object. So object A is going to be at the bottom right of object B, since we're using the center point as the origin. Which that's a completely separate test case. We're testing right, bottom, left, and top. And we're also checking to see if the collision is on the corners, which this condition would satisfy that. If that was false, it would be a corner collision, not a side collision. So that is the explanation for this. If the using vector 2, using the center point of the object for our vector origin, that would mean our rectangle height divided by 2. That would be the center point of that rectangle. If that is less than that, then it's a side collision. If it's equal to that, it's a corner collision. If it's greater than that, it's a corner collision. So that is why we check to see if it's less than the height divided by 2. Now, I also added additional to check. This is not required. I just decided to throw this in there to make it a little bit more better. But it is not required. You can leave this part out. A.velocity.x is less than 0. That means it's traveling to the left. If it's traveling to the left, it will have a right side collision. If it's traveling to the right and it hits that point, no collision is going to occur because we're already traveling to the right, so we don't need to check that. So if all this is true, normal is equal to new vector 2, we need to point in the right direction. 1, 0. We need to have a normal that points in the right direction. It's a right side collision, so we need to point the normal to the right side. Okay, left side. These are all going to be similar. If delta.x is less than 0 and absolute value delta y is less than b dot rectangle dot height divided by 2.0 and a dot velocity dot x is greater than 0. We are traveling to the right. Normal is equal to new vector 2. We need to point it to the left, which is -1, 0. And make sure you do and between delta x is less than 0 and absolute delta y is less than b dot rectangle dot height divided by 2. Okay, so that is the left side. Now let's look at top and bottom. Top side. If delta dot y is less than 0, we are moving upwards, and absolute delta x is less than b dot rectangle dot width divided by 2.0 and a dot velocity dot y is greater than 0. Normal is equal to new vector 2. We need to point upwards. 0, -1. Okay. A dot velocity dot y is greater than 0. That means we'll be moving downwards. Okay, so bottom side, if delta dot y is greater than 0, and absolute delta x is less than b dot rectangle dot width divided by 2, and a dot velocity dot y is less than 0. We are moving upwards this time. Normal is equal to new vector 2, 0, 1. So delta y is greater than 0. We are at the bottom edge. It's a positive delta y, so it's pointing downwards. And then we are moving upwards to the bottom side. Okay, now we're going to check all corners. And instead of testing for equality, I'm going to test in terms of using an epsilon value. Because testing if something equals 0 when you're dealing with floating point precision, that can become an issue when you have 0.0000000001 when you want to just test to see if it's equal to 0. A pixel value of 0.00000001, we will consider that to be 0. But we're going to use the var epsilon to test it with. 0.1. You can make this as big or small as you want. If, two opening parentheses, math.absolute value delta.x minus negative b.rectangle dot width divided by 2.0 if the distance between the delta x and the negative of the rectangle's width divided by 2, if that is less than epsilon, then we have a corner collision. And math.absolute value delta.y minus b.rectangle.height divided by 2.0 is less than epsilon. After the first closing parentheses, add an or. And I'm going to add this to a new line. Opening and closing parentheses again. And now we're going to do this 3 more times. Math.abs delta.x minus b.rectangle.width divided by 2.0 is less than epsilon. And math.abs delta.y minus b.rectangle.height divided by 2.0 is less than epsilon. After the first closing parentheses, add an or and add a new line. 2 more lines to go. Opening closing parentheses, and inside there go to math.abs delta.x minus negative b.rectangle.width divided by 2.0 is less than epsilon, and math.abs delta.y minus negative b.rectangle.height divided by 2.0 is less than epsilon. After the first closing parentheses, add an or, and this is the last line, opening closing parentheses, math.abs delta.x minus b.rectangle.width divided by 2.0 is less than epsilon, and math.abs delta.y minus negative b.rectangle.height divided by 2.0 is less than epsilon. 2 closing parentheses, opening and closing the curly brackets. And that just formatted by itself, and that's fine. Alright, so this is a check to see if any of the corners, top left, top right, bottom left, or bottom right, if any of those have hit, we're going to set the normal. So the new vector 2, delta.x, comma delta.y. Normal.normalize. Return true. So that is it for this. So at the top, we created a method that will handle rectangular collision, the very basic case between one movable entity and another movable entity. And it just calls another rectangular collision by providing their rectangles. The second method checks to see if collision has occurred between 2 different rectangles. And all it does is call rectangle.intersects another rectangle. The third method checks to see if there's a rectangular collision, and if one exists, it will give you a normal. If one does not exist, it will give you a vector 2 for the normal, in this case here. So the first thing we do is we get a delta value. If a collision has occurred, we get a delta value that gets a difference between A's position and B's position. That could be negative 3, 2, for example. Then we need to get the absolute values of those because we want to see if that value is within a certain range. For example, let's look at the right side. If the absolute value of the delta y is less than b dot rectangle dot height divided by 2, b dot rectangle dot height is always guaranteed to be positive. It might be 0, but it's guaranteed to be positive. It cannot be negative. So we need to convert absolute value of delta y, and we need to have that for the check. So we do that for all the sides, right side, left side, top side, and bottom side. Okay, now for the corners. This one is a little bit more confusing, and you might want to just check out my video game mathematics video that discusses how to create an algorithm for rectangular collision and retrieving a normal. So this is a lot less confusing than it appears. Let's take a quick look at this. Math.abs, delta x minus negative b dot rectangle dot width divided by 2 is less than epsilon. That is equivalent, I'll just write a comment up here. This is equal to delta dot x is equal to negative b dot rectangle dot width divided by 2.0. That is equivalent to that. It just uses the epsilon to check to see if maybe this won't become exactly this. If delta dot x is equal to, let's say, 37.32, but this produces 37.33, this will not be equal to. But you get the idea. This might not be exactly this. So we use epsilon to check to see if it's within a certain error. If it's within 0.1 of that, then we are fine. So delta dot x is equal to negative b dot rectangle dot width divided by 2. So negative width, that is the left corner. Remember, delta x, that gets the delta position between A and B. If A is to the left of B, delta dot x will be negative. So each one of these sections checks top left, top right, bottom left, bottom right. And if any of those is true, we get a normal based off the delta values, and then we normalize it. Remember, a normal has to have a length of 1. Delta dot x and delta dot y, that can be 300, 200. That won't have a length of 1, so we need to normalize it before we return. So that is the collision class, and that is how to get a normal from a collision using rectangular collision. I hope you enjoyed that. If you want to learn more about that, check out the video game mathematics video, which will discuss how to get an algorithm for rectangular collision detection and retrieving a normal. So next video we will discuss input mode. I hope to see you next time.